I did this part and I did this part. That's correct, right? So example 2 we needed to do because that was not done in the video. Okay, so it says given y is less than or equal to negative x plus 4 squared minus 5, find the transformations in the vertex and then graph the function. So what transformations do we see in the problem? Okay, the negative in the front tells us that it's been reflected over the x-axis. So that's the negative in the front, reflected over the x-axis. Thank you. All right, what else? What does the plus 4 tell us? Left 4. Okay, and then what else? Down 5. All right, and then what's the vertex? Negative 4, negative 5.
Like, generalization of this.
Uh-huh.
If you subtract, so is it always going to work like that, transformations, where in order to shift it to the left, you subtract from the initial value of x?
Mm-hmm.
Like, because like if you took like a more complex function, it would always be just subtract from what you put in to get the horizontal shift and add to what you get out to get the vertical shift.
Say your question one more time.
Is it always going to be like that, where you shift to the left or right by subtracting from the input, and
It is always, if it's plus 4, it's always left 4.
right,
it's always the opposite.
But does that trick where you do x plus 4 work with all functions?
Yes.
It works for quadratics and it works for
The transformations, the way we're doing transformations, that works for all parent functions. Yes. Yeah. Okay, so let's go ahead and write down the points. Now we're going to be careful because we notice that these points are different than absolute value. Because absolute value points were negative 2, 2, and these points are negative 2, 4. And then other than that, they're the same. So absolute value points, they would look like a perfect V. These points don't look like a V shape, they actually look like a U shape. And if we were to have made our table bigger for the absolute value, the next point would have been negative 3, 3. And if we made it bigger for a quadratic, it would be negative 3, 9. So if we made the table bigger, they would be even more different than they are. Right now they look slightly different, but if we were to make the table bigger, it would be like way different when we make it bigger. Okay, so we've got this. So how do we do the transformation reflect over x for the points? Okay, so we're going to multiply y by negative 1. Multiply y by negative 1. Okay, so reflect over x, you multiply the y value by negative 1. Okay? How do we take the points and move them left 4? Okay, subtract 4 from the x coordinate. Okay, and then how do we go down 5? Okay, subtract 5 from the y coordinate. So I've written some notes here, and you don't have to do these notes on every single practice problem on an assignment, but for your notes, it's good to have. So here's each of my transformations. I reflected over x, I went left 4, I went down 5, and then down here I'm just writing what I did. I multiplied the y by -1 to get that reflection over x. To get left 4, I subtracted 4 from the x coordinate. To get down 5, I subtracted 5 from the y coordinate. So that way, if I have a brain fart later, I can look back at my notes and know what to do. Okay, so this is the column that I graph. In fact, I can see my vertex right there. There's my vertex, the -4, -5. So -6, -9, -5, -6, -4, -5, -3, -6, -2, -9. Okay, so if you look at an absolute value graph, they go, that's like a normal absolute value graph goes over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1, okay? A normal quadratic goes over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7, over 1 up 9, over 1 up 11, over 1 up 13, over 1 up 15. What do you think the next number is? Over 1 up 17, over 1 up 19. It just goes up by odd numbers. That's the pattern for quadratics, okay? The reason I don't teach you guys how to do these just by memorizing those patterns is because by the time we're done, you're going to have to memorize a bunch of different patterns. Whereas if you do it this way, you don't have to memorize very much.
Or would it be over 1 up, and then wouldn't the rate of increase be 2 times a? Like, you know, if it's 0.5, it would be over 1 up 1, over 1 up 2, over 1 up 3, over 1 up 4.
Yeah. So that's how the pattern works with absolute value too. So it would change dependent on if you have a stretch or not. Yeah. All right. Let's go ahead and turn the page. All right. So these words, last time we did a lot of fill in the blank. We're not doing fill in the blank this time because we've learned the definitions before, but we learned about vertex. And if it's a problem, if it's a type of parent graph that doesn't have a vertex, then we would call it a locator point. With a quadratic, we do have something that's switching from decreasing to increasing. So for this, we're going to use the word vertex. Vertex is appropriate for this context. Yes?
When I said 2 times...
It's, Alex, this is not appropriate for that comment. Nope. Nope. Nope, not appropriate for this conversation. All right, domain and range, we're still talking about x values versus y values. So let's go ahead and do the domain and range for this sample problem. So if we look at this problem, example 3, can somebody tell us what the vertex would be? Betsy, you want to tell us? Sorry, yes. -5, -6. And if we remember from last time, we learned that one of the more simple ways of finding the domain and range is to look at the left side of the graph versus the right side of the graph for the domain, because that has to do with x values. So if I look at the left side of the graph, I can see an arrow, and I look at the right side of the graph and I can see an arrow, and I can see all the values in between, then what should I say for my domain? All real numbers, which is that weird looking R, so we draw 2 lines, and then we make an R out of it, so a double bar R, or you can say -infinity to +infinity. Okay. Now for the range, we can see, just like we could see with those V-shaped graphs, that these graphs do not go up and down forever. Because they're U-shaped, they'll go forever in one direction, but in the other direction, they're going to stop suddenly. So this particular graph goes up forever, but in the down direction, it stops. Can you guys tell which y value, because range is a y value, which y value it stops suddenly at. -6. So here we're going to say y is greater than or equal to -6. Or if we were using that interval notation where we picked a number at the bottom and picked a number at the top, we would say the bottom number that we're picking is -6, and the top number that we're picking is an arrow. So if we pick an arrow at the top, what number represents an arrow going up? Infinity. So infinity always gets a parenthesis. What about the -6 that I can put my finger on? A bracket. I can put my finger there so it gets a bracket. Okay. Increasing and decreasing interval, I believe I did not do those in the video. Is that correct? Okay. So here we put our little stick figure. Does anyone remember which letter we do for increasing and decreasing interval? Is it X or is it Y? It is X for both of them. All X's, and there's a typo right here in the notes, so we're going to fix that. So increasing interval and decreasing interval, they're both X values always. So the typo's right here. Decreasing interval is the X values. It's always X values. All right, so we have our stick figure. He is standing next to a left arrow. What X value is a left arrow? -infinity. Okay. And he starts walking. Is he walking uphill or downhill? Downhill. So what is that? Is that increasing or decreasing? Decreasing. Okay. Yeah, maybe running, maybe sliding. All right, and he decreases to the vertex, and what is the X value at that vertex? 5. Very good. Okay, so he decreases until he gets to an X value of 5. And then after the X value of 5, what is he doing? He's going back up. He's going uphill, and it's a very steep uphill. That'd be really hard. Climbing? Climbing, very difficult. All right. And he is going uphill to an X value that is at the right arrow. So what X value do we have at a right arrow? +infinity. Okay, so for the increasing interval, we are using the numbers that are on either side of the word increasing. What numbers do you guys see? 5 and infinity. Infinity always gets a parenthesis. Now with the 5, we have to think about if it should get a bracket or a parenthesis, and the only way it can get a bracket is if he's actually uphill at the number 5. Is he uphill at the number 5? No. So we're going to say parenthesis. 5 is not a number that's included uphill. Okay. The decreasing interval, so now we're going to look at the word decreasing. We're going to see the numbers that are on either side of that word. And what numbers should we be writing? -infinity and 5. And then what should we put on either side of those numbers? Wait, do we put a bracket around 5? Is he downhill at 5? No, he's kind of in between, right? So he's not walking downhill, he's not walking uphill, it's in between. So we're going to do parenthesis, parenthesis. So pretty common for your increasing and decreasing interval numbers to have parentheses. Every so often they can have brackets, but not usually. Usually they're parentheses. Okay? If you had a graph like this, you could use a bracket there because you'd be like, oh, that graph is always increasing, you're always going uphill. There's no switch from downhill to uphill, so it kind of makes sense for it to be included there. But the ones where they switch from uphill to downhill, that point where it switches, you can't really include it in one or the other. Yeah. And since most of our graphs include a switch point, that number where we switch, we generally don't get to include it in either of them. Yeah, good question. Okay, let's flip the page. We did the x-intercept, we did the y-intercept in the video last night, so we have that down. The note about continuity, you trace it with your finger. If you can trace it, then it's continuous. We know that's going to be the same, a U-shaped graph and a V-shaped graph. You can trace a U without picking up your finger. Exactly the same way you used to be able to trace a V without picking up your finger. So quadratic functions are always continuous, just like they were with absolute value. All right, so end behavior. Let's talk about the arrows. So we still do the same thing where we say as x goes to negative infinity, so this is us talking about a left arrow. So if we look at this picture, when we look at the left arrow, what do we notice? What is the left arrow doing? Is it going up or is it going down? It's going up, so we're going to say y goes to, and how do we say that y is going up? Yep, positive infinity, so we say up, the left arrow goes up. As x goes to positive infinity, so that's how we say right. What is the right arrow doing? It's going up as well, so we're going to say positive infinity here. So the left arrow goes up, the right arrow goes up. So this is how we would write the end behavior for this type of picture. Left arrow goes up, right arrow goes up. Okay. All right, so now we can talk about what happens if we have a parabola, a U-shaped graph that's upside down. So the left arrow is doing what? It's going down. So what should I write? Negative infinity. So the left arrow goes down. What about the right arrow? It's also going down. So left arrow goes down, right arrow goes down. Yeah.
I'm assuming for all like the square parabolas, the square number it's always going to have the same, either mean negative infinity at the back or positive infinity at the back.
Yeah, because with your parabolas, they either go up or they go down, so these are the only two answers you could have. Yeah, you can either say left goes up, or left goes down, right goes down. There's no other combination for this particular part of the unit. Yeah, and you'll notice these answers are exactly the same as what match the V-shaped graphs, because the V-shaped graphs had the same ends, they just had a different look in the middle, right? They either had a V with two ends going up or a V with two ends going down. So these answers actually match. Well, but it means that you don't have to. So I do want you guys to kind of understand how the answers work. You know, left goes up, right goes up, left goes down, right goes down. But these answers are no different than the last time we looked at it. They're exactly the same. Yeah.
The method for finding the vertex increasing interval and decreasing interval maximum and minimum and the minimum range are all the same.
Yep. Yep. So basically everything that we did, all the different characteristics that we found for parabolas was the same for absolute value. The only difference is that when you graph it, the points are slightly different, so the shape of the graph is a little bit different. And that when you graph it, it's a little bit harder to graph by hand as far as shortcuts go. Is that this one is a little bit easier to like fake it till you make it. The other one was like it was a straight line. So if you wanted to be lazy with this part, you kind of could, because it went over one up, one over one up, one over one up one. So if you wanted to not do the chart, you could not do the chart and be fine. This one, we're kind of getting to the point where we're like, yeah, this graph is a little bit harder. Maybe the chart would be a little bit safer to get them correct. But yeah, you're exactly right. The domain and the range is exactly the same as what it was last time. The increasing and decreasing is exactly the same as what it was last time. Finding the max and min is exactly the same as what it was last time. So we haven't changed. It's pretty similar to absolute value graphs because we just went from a V shape to a U shape. Okay. Any questions? You guys are okay? All right. So the practice assignment is actually going to feel a little bit like deja vu because I took some of the sections and just changed the types of equations, but the instructions are very similar. So take the same thing, but now do it with a parabola instead of an absolute value graph. So let me get that out. We did not shade example 2. Thank goodness we did a solid line when it was supposed to be solid, but we did not do our shading. Whew. Okay, so we did a solid line, which is good because it's supposed to be a solid line, but we do have to figure out where the shading should go. So I'm going to plug in what point? 0, 0. Okay, 0, 0 is outside of the parabola. So I'm going to test 0, 0 for x and y. 0 for y is less than or equal to negative 0 plus 4 squared minus 5. And I'm going to do my order of operations. Okay, so first parentheses, what's inside my parentheses? Okay, 0 plus 4 is 4. Okay, then I'm going to do my exponents. So what's my exponent? 16, 4 squared is 16. Okay. Next, my multiplication and division. You kind of already have your multiplication built in. You have the negative times this number, so negative 16. So I kind of have already did that just by writing it down. So I've got negative 16, and now I can finish it up. I can do negative 16 minus 5. What is negative 16 minus 5? Okay, is 0 less than a negative number? False. 0 is bigger than a negative number. Okay, so 0 is in the false area. So if everything outside the parabola is false, then where would the true part be? Inside. All right, there we go. Whew, that was a close one. All right, now our notes are done. Oh, thank goodness. We would hate to have notes that are not accurate, wouldn't we? Okay, go ahead and start working on this. And we do have notes, video notes for tonight, so I will get your sheet handed out for tonight's notes. Okay? Tomorrow. Here's how we're gonna cut the assignment down. The first page, front and back, we're gonna leave, but the second page, it starting with question 18, it asks you to do several things for every problem. And that's the part where the assignment really starts to feel long, because it feels like you just are like doing a ton of stuff. So look at the instructions for 18, 19, and 20. You're going to scribble out transformations. So for 18, 19, and 20, you're still going to find the domain and range and the max and min, but you are not going to find the transformations. In the next section, says find the increasing and decreasing interval and the intercepts. And we're going to scribble out the part where it says determine if the graph is continuous. For the next section, We're going to scribble out the part where it says transformations and vertex. We're only going to find the end behavior on that section. Okay, go ahead and turn the page. On the next page, it says find the domain and range. We're going to scribble out increasing and decreasing intervals. So find the domain and range and intercepts for each of the following. For the next one, scribble out domain and range. Okay. And then I think that's it. Any questions? Okay. So go ahead and get started, and I will pass out the page for tonight's video.